This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video we will be looking at examples of sequences. So often we might be asked to find the general term of a sequence. So in any sequence, the position of a term is represented by the letter n. So the nth term gives the value of the sequence at position n. If you look at the example below, we can see the sequence -3, -6, -9, -12, and so on. We can see that in position 1, or A1, we have -3, A sub 2 is equal to -6, and so on. The general term of this sequence is given by A sub n is equal to -3n. So this is a formula that will tell us any given term of this sequence. If we sub in n equal to 4, we get that A sub 4 is equal to -3 multiplied by 4, which is indeed -12, as we can see. Let's consider the following example for an arithmetic sequence. So we have the sequence 3, 5, 7, 9, and so on. So firstly we'll write out a small table and write out the sequence and the position of the terms. So the first row will list out the position, 1, 2, 3, 4. The next row down will have the term in each of those positions. So in position 1 we see the term 3, position 2 the term 5, position 3 the term 7, and position 4 the term 9. So as the rule for going from the position to the term is not obvious, we look for the difference between the terms. In this case there is a difference of 2 each time. So the reason we're doing this is it's not quite clear how to come up with a formula straight away that tells us generally what term goes in each position. So this difference of +2 describes the times tables that the sequence is working in. So what we should do is compare the sequence we have to the sequence given by 2 times n and see can we find any similarities or something close. So we copy the table from the previous slide with the new row being 2n. So again, position 1, 2, 3, and 4. We have our example terms being 3, 5, 7, and 9, the next row down. The third row now has the terms from the sequence 2n in their positions. So position 1 of the sequence 2n has the term 2. Position 2 of the sequence 2n has the term 4. The next is 6, the next is 8. Now we look at the fourth row, which we've denoted by the difference between the 2n sequence and our sequence, our example. So the difference is to get from 2n to our sequence, we need to add 1 each time. So to get from 2 to 3, which is both in position 1, we add 1. To get from 4 to 5 in position 2, we add 1, and so on. So if the position is position n, we know then to get, for our sequence, to get the term, we first of all need the sequence 2n, and then we need to add 1. So simply the nth term for our sequence is 2 times n plus 1. There is a general formula for this. The general idea is to start with the first term, a, and add d to move to the next term. So the terms of the sequence are t1 is equal to a plus 0d, as we haven't added any of the d yet, being the common difference. t2 is then a plus 1d, t3 is then a plus 2d, and so on. So that gives us that in general, the nth term is tn equal to a plus n minus 1 lots of d. And we'll look at an example now of a geometric sequence. So if we consider the example from the previous video of 3, 15, 75, 375, and so on, we saw that the pattern was to multiply each of the terms by 5 to obtain the new term. So we can rewrite this sequence by factoring out the 5. So we will leave the first term as it is, as 3. The next term, which is 15, can be rewritten as 3 times 5. Next term again, the third term, can be written as 3 times 5 squared. 3 times 25 is 75, and so on. The reason for doing this, we'll see, is that t1 is equal to 3, t2 is equal to 3 times 5 to the power of 1, t sub 3 is equal to 3 times 5 to the power of 2. And we notice that tn then can be written as 3 times 5 to the power of n minus 1. And we see that for example, in t sub 3, the number 3 and the number 2 are related by just subtracting 1 from 3, which gives us t sub n is equal to 3 times 5 to the power of n minus 1. And again, there is a general formula for this. So the idea is to start with the term a and multiply r to move it to the next term. So the first term of a sequence will be t1 is equal to a times r to the power of 0. And notice that the common ratio r, regardless of what it is, if it's raised to the power of 0, will be equal to 1, giving us that t1 is equal to a, which is what we wanted. t2 is then equal to a times r to the power of 1, which is just a, our first term, multiplied by our common ratio, just once. T sub 3 is equal to a times r squared, and so on, giving us that t sub n is equal to a times r to the power of n minus 1.